This video is about three-dimensional plotting in Matlab. As you'll see, plotting in 3 dimensions is almost as easy as plotting in 2 dimensions using Matlab's built-in functions for plotting. We'll talk about both line and scatter plots as well as surface and mesh plots in 3 dimensions. First, let's look at scatter plots, which are mostly used for 3-dimensional data or anytime the values are unsorted and you wouldn't want to connect each data point to the next with a line segment. So for example, I'm going to plot these 5 data points as a scatter plot in 3 dimensions. The first thing I need to do is create arrays of the x, y, and z values, putting them each in the same order. So my first x value will be 1, my first y value will be 1, my first z value will be 3. Okay, but these are arranged in terms of first all the x values. So here's an array of all of those x values, 1, 1, 2, 3, 3. Y values, the corresponding y values in the same order. And the z values, again, in the same corresponding order. Okay, if I want to plot them in 3 dimensions as a scatter plot, so each data point as maybe a black star, then I use the plot3 command, very similar to the plot command, except we give x values, y values, and z values. And then if you want any sort of modifier, which in this case I want black stars, so I use k asterisk. And with that we get our plot of those 5 data points in 3 dimensions. If we want to make this look a little nicer, then we can turn on a grid with the grid on command and then start giving labels to the axes with the x label, y label, and z label commands. And now we have a nice looking graph. If you want to rotate the view, there's a button for that right here to rotate the view in 3 dimensions, and you can get whatever camera viewpoint you want for this 3-dimensional graph. Okay, if we want, instead of a scatter plot, if we have data where we want to connect each data point with a line segment, such as this 3-dimensional parametric equation, then we can do that again with the plot3 command. First, for this parametric equation, we want to set an array of t values. So that was from 0 to 12 pi, and if I want to have lots of values in between, then maybe I'll count by 0.01. So now we have roughly 4,000 t values from 0 to 12 pi. And the x values will be the square root of t. Each one of those square root of t values multiplied by the sine of t. And the y values well, they're roughly the same thing, but for this parametric equation multiplied by the cosine of t. And the z values are given by 0.25 times t. So now we have 4,000 values of x, y, and z. They're all in the same order, and to make this a line plot, we use the plot3 command again. Give our arrays of x, y, and z, and if we're fine with blue line segments connecting each of these data points, then we can leave it just like that. And here we have this parametric equation which looks like a spiral. Again, if we want to turn grid on, we can do that and give our labels. And here's this graph now, this 3-dimensional parametric equation graph. Finally, let's look at surface and mesh plots. So this is normally used for a function of this form. Z is a function of x and y. So z is defined over a sort of a 2-dimensional space defined by a bunch of x and y values. And the example I'll use is this function. Z is equal to the exponential negative x squared plus y squared. In this case, the easiest thing to do, we need to get a 2-dimensional array of x and y values to define z over. And one easy way to do this is to use a command called meshgrid. So if you create a range for your x values, let's say -2 evaluated every 0.1 up to +2, and another 1-dimensional array representing your y values, I'll use the same range here. You can then get a 2-dimensional array of x and y values using this meshgrid command. which takes in the x range and y range and gives back out x and y values defined over this entire two-dimensional field, in this case going from x is -2 to +2 and y going from -2 to +2. Okay, so now that we have x and y defined as a two-dimensional array, we can evaluate z using that a function we had earlier for every one of those pairs of x and y values. So z is equal to e to the negative x squared plus y squared So you can see capital X here is 41 by 41, Y is 41 by 41, as is Z. So we have 41 by 41 data points. And first let's use a surface plot. Command for that is surf, and you give the 2D array of X, Y, and Z values. And here's what we get, a nice looking surface plot. Again, you can use the rotate 3D if you want to get a different viewpoint. Similar command, just a different drawing style, is to use mesh. It's roughly the same thing, but just a different type of drawing. You can see it's more of a mesh instead of a surface. Or even if you want, you can get something that looks like a contour map with contour 3, X, Y, Z. And so now this is the same data, but it's plotting sort of contour lines like you might find on a topographic map. Okay, that's an overview of how to make plots in 3 dimensions. If you want much more on the details of how to change the looks of these plots, then use the doc command for plot 3 or surf mesh or contour 3.